Okay, we'll get started. First thing, I'm going to answer the problem 2-3 in chapter 1. Okay, you work on this one, but I'm going to give you more idea what this one really is. Okay, so first thing is that before we go into this problem, then you need to know one thing. Okay, one thing is like it's very important in computer science to create something called random function. Okay, there's a need to create something called random function. So random function will generate a number between 0 and 1, but not including 1. Okay, you create some number that's between 0 and 1. So it can be 0.00001, can be 0.99999, okay, whatever. But the number should be between 0 and 1, including 0, but not including 1. Okay, so this one, for example, we have a random function u times 100. It should be able to generate number from 0 to 99.99. If you actually convert this one to an integer, then it will be 0, 1, 2, up to 99. So 99 possible numbers. And as for how this random number can be using, we are not covering it here, okay? One thing that I just want to say is this random number is very important, okay? So Sarah, is that okay so far?
Yeah.
You have finished APCSA, so you know the importance of the random number, right? So it's like that. Now, the question is like, how can we generate this random number? Okay? So how can we generate a number that's random? There are many ways that you can generate a random number, okay? So one way to generate this random number is, how about this? How about I use a thermal generator? Okay, so basically there is a electronic device that can be generate a temperature from 23 degrees C to 45 degrees C. So we use actually a measurement. So it would always generate a number from 23 to 45. Then this number that's associated is x. So basically x minus 23 divided by 45 minus 23. You should get a number between 0 and 1. Right? Does that make sense?
Yes.
And we can use that as a thermal random number generator. Okay. We can use that as a thermal random number generator. So there are a random number generator in the market that you can buy. A lot of them using thermal way or electronic way to generate it. So you can actually call it thermal random number generator. Okay, and it's used to generate a lot of random number generator. Okay, and you see, we search this, there are many circuits that you can use to create thermal number. Okay, and this part, I don't go into any further. Just let you know that it's possible to design a IC chip to generate random number generator, but this one you need to spend money to buy it. Okay, you need to spend money to buy it. So it is not a cheap solution. So instead, people think about, how about can we generate a random number and then using computer? Okay, using computer to generate a random number. We call it pseudo random number generator. Okay. So it's not real. It's actually pseudo. Pseudo means fake. Okay. Fake random number generator. And it should be, let's say, creating a 0.1, 0.7, 0.4, 0.2, 0.8. No actually reason, just randomly generated, but it will become a sequence. It's not real random because actually it's jumping around, but it's not real random number. But you will be able to create such a sequence so you can use it for random number purpose. Okay. And it happened to be an example in this chapter 1. Okay. It happened to be an example in this chapter 1. They give a very low cost, but lousy, not good example of random number generator. Okay. They give an example that actually is not good. Not really high quality random number, but it will work. Okay. But it will work. So in the textbook, if you read that, there's a random number generator that you can use. Okay, so now we are going to generate such a random number generator using function. Okay, using function. So let's actually use the idle. Okay, so this one, let's call it chaos. The program actually is called chaos. Okay, so that's actually save this program as. So if you look at the textbook, it say that it's a chaos function. Okay. So Sarah, you see that, right?
Yeah.
Yeah, okay. So this one, let's actually create BF2, okay? Create a directory called BF2 this second week. Okay, so right here, this function is called chaos. I know everyone work on this problem because you finished the homework. Okay, and Harrison, are you okay so far?
Yeah.
So this chaos function, you want to create a random number generator, okay? So now before we go into the chaos, okay, let's actually look at one function. This function is a call for this chaos function, and it is x times 1 minus x. So x times 1 minus x, you can actually change it to minus x plus x, right? And you can be transformed to minus x squared minus x plus 1/4 plus 1/4 outside. So you'll be minus x minus 0.5, 0.2, 1 over 2 square plus 1 over 4. So far, okay? So far, okay?
Yeah.
Titus, is that okay?
Yeah.
We do have this x times 1 minus x, right?
Yes.
And then there's a 2 or 4 or 3.9 before it, right? So let's assume this is called y. So let's make a chart for this y. So x over y. So y equals this is f of x, okay? So let's assume that the data is 1. So 1 minus 1 over 2 square, that would be minus 1/4 plus 1/4. So at 1, it actually is 0. At the 0 is also 0. Okay? Then at half, if x equals 0.5, what will happen? Harrison, if x equals 0.5, 1 over 2, what will happen? What will happen to y?
It will go down.
What would be the value for actually x equals 1 over 2?
1/4.
1/4, yes. This part will become 0, okay? So h is 1/4. So the line is like this. It's a quadratic curve. It's a parabolic curve, okay? Harrison, are you okay so far for the parabolic curve?
I think so, yeah.
Have you learned this math?
No, not yet.
Not yet, okay? So you may ask your father, okay?
Okay.
He is very good in math, so if you don't know it, you can ask him after class, okay? So anyway, this is the function we see, and it's 1/4. So, Sarah, what is the use of this function?
Generate like numbers.
Hmm?
Like generate random like numbers.
What kind of numbers? Random
Like
numbers.
random. Yeah.
So if you get 0.5, you get 1/4. You get 1/4, what happened?
1/2.
I think it probably 1/4 of the something you can calculate, right? So you will get 0 point something, right? So what's
Yeah.
wrong with this function though?
Like if
In
it's
terms of our goal, we want to generate 0 to 1. But what's wrong with this function?
it can at like one half or something, it just keeps
You can only
going
go
like,
from 0 to 1/4, right?
yeah.
So Titus, how to fix it?
I don't know.
Your target is 0 to 1. Now you can only generate 0 to 1/4. How can you improve this function?
Maybe vertical stretch.
How to vertically stretch it?
You multiply the function by 2.
By 2, that's only half.
Oh, you multiply it. Yeah, what?
Multiply by how much?
Uh,
Say it. I know
1/2.
know. One
One.
half you actually drop down. You
Oh,
not
4.
4. Yes.
Okay.
So 4, you go from here to here, you actually reach 1 here. So this one will give you 0 to 1, but including 1. It's still not what we want. So it's possible you put a 4 before it, then it will become the green curve, right? So 4 is not a good number, so we choose 3.999999999. That would be the best number to reach our goal. Does that make sense?
Yeah.
Sarah, is that okay so far?
Yeah.
How about Harrison? Are you okay so far?
Yeah.
Times 3.9999 something would be the best solution. Because when you are 0.5, x equal 0.5, you will reach 0.9999. Okay. Okay, but to make the whole thing clean, the textbook example choose to use 3.9. They don't use a 4. They use a 3.9. They don't use a 3.99999. So they use a 4. They use a 3.9. Okay. And then Titus, if you choose 2, what's wrong with choosing 2?
2 will just
Just
yeah, it will.
half of the function, right?
Yes.
That's answer you the third problem that I want you to think about it. Does that make sense?
Yes.
So that will not be enough. That will not be enough. So let's go back to our program. So this function, if you write a function, you should define a function called chaos. Okay, this one you will get a number called root. Okay, let's call it root. The first number root. Okay, so you get a root, and then you say x equals root. Okay, so for I in range of 10. Okay. So here, let's think about it. This range function, you put a 10, you will generate the number sequence of 0, 1, 2, 3, up to 9. Okay. The range function will do this. Okay, so you have an I. Okay, you have an I. So this one totally, the for loop will do things for 10 times. for 10 times. For I equals 0, you will do 1 time. For I equals 1, you will do 1 time. For I equals 2, you will do 2 times. 3, 4, 5, 6, 7, 8, 9. So 0 to 9, totally 10 times. So each time of it, you will have x equals x times 1 minus x. Okay, before you do that, let's do this. Let's do print x. No. That's after it. Okay, that's print it before it. Okay, print it before it. So this one actually is the next x that we call it y. Okay, it actually is current x times 1 minus x. And we say this is not enough. So before it, you need to multiply by 3.999999999. Okay, let's assume this is the number we deserve. And having that, you should able to print 10 number. Should print 10 random number of from 0 to 1. Okay, so now we have chaos function, so that's a wrong chaos. Okay, so define function is designing a function, and chaos function call, you will call it and run it. So here we need to have a number. So this number, that's assume this is f number. Okay, so float, and then input, enter the root number. Okay, look okay.
Yeah.
Okay, that's actually save, and that's actually wrong it. So you wait for a number. Let's just try 0. Missing the positional argument. Let me see. Oh, we need to put that F into the chaos. Sorry. One more time, okay? I forget it. So let's run it again. So I choose 0. It will always be 0. So 0 actually is not good, okay? Maybe the number is too small. So so this is actually still another problem, okay? Let's try another one. Let's try 1. 1, you will also get a 0, okay? So it's not good on these two numbers. So let's try another one. So let's try 0.1. So 0.1 work, okay? Let's try another number. Let's try 0.5. It works, okay? It's a small number, but it still works. So let's try another way. Let's try import chaos. So that function is getting in, okay? So we run it. So we try 0.5 again, okay? So I call chaos, the chaos 0.7. Oh. It was run the chaos function by 0.7, okay? So this one is how you generate a random number. It's not a fair, very good random number generator, but you will generate random number, okay? So right here, if we change it to 3.99, okay, let's run it again. So run it. So this one, you still put in a 0. It's still dead at a 0, okay? It's not random. So let's try another one. Let's try run module. If this one is 1, you will still get 0, so it's still dead, okay? Because these two numbers would make the number really dead, okay? Really dead. Okay. So how can we avoid that problem? How can we avoid that problem is that's plus a 1e minus 9. So 1e minus 9 is a very small number, okay? But this whole thing should be times 0.9999, because when you have a 1, you will be over 1, okay? And we don't want to be over 1, so we time these two numbers to avoid the 0 problem. So let's time wrong it. So this time let me put the 0. It worked, right? Does that make sense? So this time let's wrong it, and I put a 1. It worked. That means I'm smart. I know how to get around the problem. Does that make sense?
Yeah.
Yeah.
So here, if I change it to the number that is 2.0, and let's assume that we do not have this one. Let's comment it out. Let's actually do the way that the program has. You still have x equals root. Okay. And what happened is that you run and you try 0.5. You get 0.5 and you are dead. So this problem actually at the 0.5, 0, and 1, you will be dead. You are not really random numbers. So we not only suggest such a change, but also we are not only suggest this number right here, not only is multiplied by 4, and the textbook doesn't need you to adjust the x, but I do adjust it. And then let's run it. This is a perfect version, okay? 1.0. Okay, one more time. And then 0. Okay, one more time. This is programming, okay? Programming is that you want to achieve your goal and you want to avoid the problem that you create, okay? You need to put something. There is no reason. We understand what happened, but there is a very, very, this is just experimental number. You can try different numbers, smaller one or closer to 1, okay? Whatever number you can try. But there is no theoretical proof that these are best, okay? So it's just an experience number. And sometimes this experience number work, okay? Does that make sense? Even this 3.99 is also an experience number. Theoretically, it should be 4. But we need to pick something close to 3.9999999, okay? This is computer science, okay? We live in real world. We want the program to work. And we want to find a solution that make our program work. So right here, I'm going to attach that file for you, okay? I'm going to attach that file for you. So look at this chaos, okay? It is a version that enhanced from the textbook. It's different from the textbook. You try the homework, but we enhance it, okay? The theory behind it is the chart that we just draw, okay? And why I'm discussing this is that I want to teach you more advanced stuff, okay? More advanced stuff. And making sure you enjoy it, okay? Enjoy it. So this is a function of creating random numbers, okay? Using a simple function of x times 1 minus x and scale up to a certain level, okay? Okay, so that portion is the homework discussion. Any questions so far? Any questions so far? Hello, any questions so far?
No question.
No question. We are going back to our brief Python course. Okay. Last time we introduced the basic data type, basic syntax, and we finished this portion, and then we are on the data type, right? Up to here, we are on the data type, and we do introduce what are the data type: integer, floating point, and the string, right? And we do conversion between those data types. Today, we are going to continue to discuss our numbers, our tuples, and our string, and maybe also the list and the string. Okay, so basically these are the data types we will discuss today. Okay. So the first thing is that, okay, we talked about this last time. Okay, the integer type last time. This I think we pass it, right? This we Boolean value we pass it. We show you a little bit of the string and list, right? Okay, now let's actually look at one example. So today we are going to introduce the data type of the character type, char. Okay. Okay, let me test Titus. I know you know some computer science. Okay, so what is a character?
It's like a piece of the string.
A piece of a string. And what is the theory behind, what kind of coding you use in character? If you have an A, what will happen?
Oh,
What will be stored in computer?
string.
What kind of string?
I'm not sure.
How about Sarah? Do you still remember?
Is it like the integer?
What kind of integer? For A specifically, what will it be?
ASCII.
Yes, ASCII code, okay? So this is what we want to teach today. ASCII code. ASCII, okay, it stands for American Standard Code for Information Inter-Exchange. Okay, it stands for American Standard Code for Information Inter-Exchange. So that already tell you the purpose of the code is for information inter-exchange. Like you send me an email, and your character will be converted to the ASCII code and transmit to me, and I'll receive ASCII code, and I know what you say in email. Okay, just like here, I type something, American Standard Code for Information Inter-Exchange. Okay, so from my side is these are words, but each letter will be converted to 65 something something something. A is 65. Okay, it will be sent to you, and then it will be in binary format of the 65. Okay. Did we teach you conversion from binary to decimal to binary? Did we teach you already or no? Titus, did we teach you conversion from decimal to binary or no?
I don't think so, no.
You don't think so?
No.
Okay. So we'll explain it, okay? I'm sorry. Let me change back to screen. Okay, so basically, American Standard Code for Information Exchange. So A A, okay, A, you actually transmit this scene to you. It actually is 0, 1, 0, 0, 0, 0, 0, 1. This is actually 65 in binary. Will be sent to you. So this is actually equivalent to an A symbol. Okay, this is what I will send to you. If I send you an email, it will be such a binary number. So there's a table called ASCII table. Okay, you search internet. There's an ASCII table you need to know. Okay, so basically this ASCII table is in this website. Let's copy to the group. Okay, so you can download the table. Is that very important? Yes, it's very important. You must remember it. Otherwise, you don't know what it is. Okay, so this is ASCII table. So let's look at this ASCII table now. Okay, let me actually open this in another tab. Okay, just the picture part. Okay, so here that is. Okay, before we start to read this whole thing, let's look at one thing that you need to know is the conversion from decimal to binary. Okay, from decimal to binary. So let's assume that we have a number that's actually is 57. I think this one Sarah already know. Okay, we convert it to binary. It divide by 2. It should be 28 remainder 1. Is that okay so far?
Yeah.
Yes.
And then divide by 2, it will be 14 remainder 0. Is that okay?
Yeah.
Yeah.
Divide by 2, you got 7 remainder 0. Divide by 2, you got 3 remainder 1. Divide by 2, you got 1 remainder 1. So you read from here to here, it'll be 1, 1, 1, 0, 0, 1. This one's binary. So 57 in decimal means 1, 1, 1, 0, 0, 1 in binary. Okay? So that's how you convert the 57 to binary. So every symbol that has an ASCII code, it will be converted to binary, and then in binary, you send it to the other party. Okay? So this one's binary. So this is a binary. We can further group them into 4 bit. So this one is a 9. This one is a 3. So 39 is a hexadecimal code, base is 16 core. Okay, and because base 2 is very hard to read, so sometimes the memory actually have using the hexadecimal base 16 to show your memory map. Okay, show your memory map. So what I want to say is on this table, okay, on this table, let's see. Okay, on this table that we see right here, it gives you the decimal code for each symbol. It also gives you the hexadecimal code for it. So for example, your decimal 0 to 31, this whole part is control code. Control code means that change line is actually number 13. Line feet, okay, 12. Okay, this is 9 feet, change the line, okay. Number 12 is phone feet, change your page, okay. So whole control code for each of the control code is 0 to 31. In hexadecimal is 0 to 1F, Okay, this is a little bit more complicated. But anyway, you don't need to know those control code. What you need to know is that A is from 65 to 90. Okay. A to Z lowercase is 97 to 122. These two sections are most important part you need to remember. Is that okay so far?
Yes.
Yeah.
So for example, I want to transmit a H, you transmit 72. That would be hexadecimal value of 48. Okay. Does that make sense?
Yeah.
Yeah.
So now this table is good. The next thing that we need to learn is, okay, let's go back to idle. Let's go back to idle, okay? So let's go back to idle. So now I'm in idle, okay? So let me push a few lines so the garbage is gone, okay? Now, I want to know about the call for A. I would say available. I'm sorry. How comes it actually keep give me errors? I'm sorry. Let me try again. Okay. Oh, it should be here. So A equals ORD of A. So this order function will give you the ASCII code in decimal for you. So that's print A. Print A, you get 65. Does that make sense?
Yeah.
So H equals ORD of the capital H. You print H, it'll give you 72. But if you do H equals ORD of lowercase h, it will be different. It will be 104. So lowercase h and the uppercase h are sent in different ASCII code. Is that okay?
Yeah.
So this is order function, ORD function. Okay. ORD function is convert the symbol to the ASCII code. Titus, is that okay so far?
Yeah.
Now, next one is how about what? How about let me do this? Let me do A string equals CHR, character of 65. And then let's print A string. So we convert 65 back to the symbol. So your symbol or string converted to number ASCII code is using ORD. Your symbol converted back to the string is called char, CHR, character. So this is the basic character operation. Okay? Does that make sense?
Yeah.
So now, now I have a need to create all of the A to Z symbol. How can I create A to Z symbol in my program? So let me create this new file. Okay. Let's call this function ASCII. So this one, let's call it ASCII program. Okay. So this is ASCII.py program. So this program is ASCII .py program, okay, to generate a string of A to Z, capital case, okay? We want to generate ASCII of A to Z. So let's call this one called alphabet. So alphabet, that's assumed actually is empty string. Okay, so this one, alphabet. Now I want to create A to Z. Okay, so for my ASCII in range, okay, from where? From 65 to 91. Okay, so this one range function will generate the number, a number from 65 to 90, not including 91. So 91 not included, okay? It's something like this, okay? I'll generate a number that's actually between 65 and 91, okay? So let's see. Okay, so we got that number, a ASCII number. Okay, this one is reader word. We cannot use reader word. So let's just use A. I'm sorry. Actually, ASCII is a reader. It's a purple word, so it's actually ASCII. So let's use A. So this A, I would say this A is a character CH equals actually CHR of A. Okay, so this one convert the ASCII code to a character. Okay, so alphabet equals alphabet plus the character. So you append that character to the alphabet. And then once you are done, you print your alphabet. So every letter from 65 to 90, we find its character symbol and add it to alphabet, add it to alphabet, add to alphabet, add to alphabet until it finish at 90. 91 will not be included. So let's see, wrong. So it create A to Z string. Is that okay so far?
Yeah.
Harrison, is that okay so far?
Yeah.
So one thing that we learned right here, two things that we learned here. One is you convert your number to character. Second one is your empty string plus A. So this one become A string. Then your A string plus a B, it become a string of AB. Then AB plus a C, it become ABC. So you keep going until Z, you become A blah 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 to Z. Okay. So the first thing, alphabet equals double quote is a empty string, but every time we add one character to it, add one to it. Okay, so every number from 65 to 90, 91 means 91 not included. So it's from 65 to 90. You actually convert that number A into a character and then append it to the alphabet. So this is how we generate every alphabet later, okay? And put it into a string called alphabet and we print it, okay? Any questions so far?
No.
No question. I'm going to post the program to the group so you can study, okay? Okay, this is ASCII, okay? Okay, so this one is the basic operation. Teach you two things. One is one single character called character. It is a string of one letter. Okay, and you can convert it using ORD. You give you ASCII code, and you do CHR. You will convert. Let's assume this is A. You will convert it back to a string. Okay. The other thing is your string plus another character or string. It will become a longer string. Okay, it will become a longer string. These are what we teach so far. Okay, and another one is range function with two numbers A and B. You will create a number from A to B, but not including B. Okay, these are three things that we learn from this program. And later we will continue to learn it. Okay, very important. So this is the character type that we learned today. Okay, this is the character type that we learned today. So we want you to work on the solo learn because we want you to practice on it. Okay, and in the class we teach you the kind of the story that you need to learn for each data type. So today we introduce the ASCII code. Okay, for the string and basic string operation plus, okay, concatenation of the string plus. Okay, that portion we finish. Okay, another thing is this Boolean type. Okay, Boolean type. Boolean type, I think Sarah or Titus may know, okay, but this Boolean type we still need to teach from the fundamental part. Be patient, okay? So Boolean type, because the person called George Boole, okay, this is a mathematician in the 19th century. His lifetime is overlapped with the Abraham Lincoln, okay, whatever. But this person, he invented binary numbers and Boolean algebra. So because his name is called Boole, so you add the word an, this one become Boole's. Okay, so it's a Mr. Boole's number. We call it binary number. If it's a Boole's, Mr. Boole's algebra, we call it Boolean algebra. Okay, Mr. Boole's variable, we call it Boolean variable. Okay, so basically all Booleans, Boolean variable, Boolean algebra, Boolean numbers. Okay. Any questions so far?
No.
No.
So what is Boolean? Okay, now this question is what is Boolean? Okay. So we will create a new file. I think this one last time we may already teach you, but I'm going to use it again. Okay. I may have talked about this last time. Okay, but did I talk about the Boolean value before? Yes or no?
I don't think so.
Okay, not yet. Okay. So this one is called Boolean.py. Okay. So we have a variable b equals, let's see. Let's actually get a number. N equals integer. Okay. Input from enter a number. Okay, so we get a number called n. Okay, we get a number called n. And then we say Boolean variable b equals n, take modulo by 2 equals 0. So percentage sign means take the remainder of the 2. So Harrison, If you have 17 divided by 2, what is the remainder?
The remainder is 1.
So 1 equals 0 or not? 1 equals 0 or not?
Wait, I don't get it.
1 equals 0 or not? Just answer me 1 equals 0 or not?
No.
No. So that means that if your remainder is 1, what is the nature of this number n?
Is it like 1?
When n take remainder of 2, and what is the nature of n? If this thing equals 1.
Like odd?
Odd, yes. This is odd. So it's odd. Okay, so when n is odd, what is n modular by 2 equals 0? Harrison, what would be the, when you compare 0 and n take modular by 2, what will happen?
It won't be equal.
It won't be equal, so we say false. So let's assume that n equals 8. Then a take modular by 2, checking with 0, what will happen?
It'd be true.
It will be true. So this one means is even. Okay? So false means it's odd. So what I want to say is that this n take modular by 2 can check whether n is even or odd. Okay? This one I think Sarah know it, Titus may know it, so that's why I asked Harrison. Okay? Okay, so we got that. So we say if B, then print n is even. Okay? Otherwise, we print n is odd. Okay, this one we talked about it before. Maybe, okay, maybe before. So you do if and put in some Boolean value. It may be true, maybe false. If true, we go to this part. If true, we go to this part. If false, we go to this part. So n divided by 2 equals 0, we say it's an even number. Otherwise, we say it's an odd number. Okay? Any questions so far?
No.
About Titus, are you okay so far?
Yep. No
So
questions.
This scene does it save us even the py. Okay, we teach in a lot of detail, so a little bit slow right now. Okay, because I'm not sure whether you guys know everything. I know Sarah may know it. Okay, so let's go. So let's have a number 17. It is art. Okay, one more time. So let's run. And let's enter 8. Enter 8. That will be even. Okay. Any questions so far?
No.
So this one we learn what is Boolean number from this function. Second, we also learn is what is a Boolean function, Boolean value. Okay, what is Boolean? We also learn the if structure. Okay, we also learn the if structure. So that's a Boolean type. So far we learn floor type. We have learned floor type. We also have learned the integer type. We also have learned the Boolean type and ASCII code. Okay. So basically we learn integer, we learn float, okay? We also learn Boolean, okay? And now, before we go to the sequence type, okay, before we go into the sequence type, let's try one more thing. Okay, let's create a new file. So this one I'm going to save as. This one I'm going to save as temperature, temp, okay, temp function, okay. So it's called temp.py, okay. So this temporary function, I'm going to read in a value that's the Celsius. Okay, so Celsius equals float of input or enter the temperature in Celsius. Okay. So we have a value that's actually in Celsius. We convert it to F, so C times 1.8 plus 32. Okay, so we convert it to a Celsius value. So we do print, okay. So C comma, okay, backslash U 2103, okay, is F backslash U 2109. So what is this 2003 and 2009 things? Okay, we will see it later. Okay, so that's actually run the module. So enter a temperature, that's a 37. So 37 degrees C will become 98.6 degree F. So the backslash U 2103 is this symbol of degree C. Okay, backslash U 2009 is this symbol of degree F. Is okay? This U means Unicode. Sarah, what is Unicode?
It's like ASCII, but for all the other characters that ASCII doesn't have.
Okay, good. Harrison, do you hear her?
Yeah.
So ASCII is for English. So ASCII only 0 to 255. So there's only 256 symbols. So ASCII cannot store Chinese, cannot store these symbols. So a code called Unicode is invented to store all of the other characters. So Titus, is that okay so far?
Yeah.
So let's print one thing. Let's print backslash U 5468. Okay, let's see what 5468 is. This is 5468. This one is a character like this. Okay, so Harrison, what is this later? This is Chinese character.
Zhou.
Yeah, Chao Dynasty, right? It's my last name, okay? My CHOU is this one. Titus, is that okay so far?
Yeah.
Are you going to take AP Chinese?
Yes, probably.
Okay, so this one Unicode Chinese, okay? So let's try another one. Sometime it actually is /U 2660, okay? So let's see 2660, which one it is. It is space, okay? It is space. So let's try, okay, this is good enough, okay? So basically, I just want to tell you that some of the character that's not in ASCII, how can we show it? Okay, how can we show it? Okay, up to here, okay? I don't want to make it too hard. We can teach you harder thing later, okay? Okay, so we finished ASCII code, we finished Boolean, we finished the integer floating point, we finished the string, okay? Next one, we are going to teach you the sequence type. It's called string, list, and tuple. Okay. So these are three things you need to learn it. It's a collection, data collection. Okay. It is data collection. It is called data collection. So data collection, when we have a double code A, B, C, okay, or double code 1, 2, 3, A, okay. Using double code, single code, or triple code. Double code, single code, or triple code, triple code. Okay. This whole thing, we call it string. They are all strings. String is a collection of characters. Okay. String is a collection of characters. So let me take a picture. Okay. So later you can take notes. Okay. So string is a collection of characters. Let me erase everything. Okay. It's 9:02. Harrison, you need a break or no? Anyone need a break?
I'm good.
You're good? No? Okay. We'll continue. Okay. If no one need to have a break. Next one, tuple. Tuple means multiple variable. Sometimes we also call it vector. Okay. So a variable can be a tuple if you use parentheses. Okay. You use double quote as a string. You use a parenthesis. It is actually called tuple. Okay, it's called tuple. So when will we use tuple? Usually it's for coordination. Okay, it's for coordination. So let's see. So let's go back to the idle. Okay. So we can say a point P equals 1, 2. This is a point, okay, and then we say print P0, you get 1. Print P1, you get 2. So basically a P is a point. A P is a point. Okay, the first element we call it P0, break it 0, okay. Second element we call it P1. And this is actually talking about a point. In the coordination is 1/2 is over here. This one is 0, 1. I'm sorry, 1, 2. Does that make sense? Does that make sense?
Yeah.
Yeah.
This we call it tuple. Okay, today we just want to introduce this data type. It's called tuple. Later we have a whole chapter to talk about tuple. Okay, so at this moment we are not trying to cover everything about tuple. You just need to know it. Okay. Okay, so we are going to teach you multiple input. Okay, multiple input. In a way, we want to teach you multiple input. Okay. So in a way, let's try a function. Okay, let's try a function. This one called point.py. Okay, so that's actually save us. We are going to enter a point address. Okay. So let's assume that we have a point.py, and then p equals P equals input. Enter the coordinate of a point. And this whole thing, it would be a string. And that string need to be evaluated. And you assign to a P. Okay, so let's assume this is P1. It's P1. Okay. And that's actually copy this and create another point called P2. Okay. Now I want to calculate the distance. So the distance will be equal P1's 0 minus P2's 0. Okay. So let's not do it here, or let's call it X distance. Okay. Now also have another one called Y distance. So Y distance equals P1's 0, 1 minus P2's 1, and then distance equals mass.sqrt or xd times xd plus yd times yd. Okay. Here we had a mass, so we need to import mass. Okay. Get mathematical library. So this one is trying to do this, you have a point. This point is P1, okay, 0, and the P1, 1, okay. The other point is P2, 0, and the P2, 1, the XY, okay. Each one's XY. And here, the distance here is YD and the XD. Okay, is that okay so far?
Oh, I have a question.
You have question? Ask me. Yeah.
Why why do we need like the eval? Why can't we just do a P1 equals input something something?
Input something give you a string, don't give you a point. Eval will convert a string. So you basically get a string of 1, 2, but that's a string. Then we need to convert it to a tuple. So eval will convert it to tuple.
Oh, okay, thank you.
When you read it in, it's only a string. It's not, we don't know what it is, okay? It actually is a string. Good question, though. That's a very good question. How about Sarah? Are you okay?
Yeah.
How about Titus? Are you okay?
Yeah.
So this one is to calculate the distance between 2 points, okay? And the 2-point coordinate is what you assign, okay? What you assign from outside. So let's actually try it, okay? Let's try it. So there's another data type we introduced today that's called tuple, okay? Let's call tuple. Let's see. Okay, so we want to run this program, okay? So run this program. So you enter a coordinate. Right now you don't enter 3, don't enter 4. You enter 0, 3. Okay. So that is the string. Parenthesis 0, 3, that's a string. So when you go in, you need to convert it to tuple. The evaluation function is called eval. Okay. And another point is 4 and 0. So that's actually, oh, I did not print the distance. Okay, I'm sorry, I forget to print the distance. So let's go back to this function. At the end, we need to print distance equals comma, distance. Okay. Let's try again. So we do 0, comma 3, 4, comma 0, and it's a 5.0. Does that make sense? Does that make sense so far?
Yeah.
About Sarah, are you okay?
Yeah.
About Titus, are you okay so far?
Yeah.
So this one is called tuple, okay? Tuple is a vector. It is a point usually used for coordinate, okay? Usually used for coordinate. Next one, we are going to introduce another type that's called list. Again, we are not trying to go into the detail for the list type, okay? We are just trying to introduce the list type for you, okay? So there's another collection type called list. So string using double quote, tuple using parentheses, list using bracket. Okay, so this is sometimes some people also call it array, but it's not really an array. Okay, it's more powerful than array. We call it list. Okay, so basically, let's look at what is list. Okay, so let me actually create a new file. Okay, so this new file, let's call it square.py. Okay, so I have a equals 0, 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9. Okay, let's assume that this one is the sequence from 0 to 10. Okay. I would have a B. Okay, so I have a B. So B equals empty list. Okay, this one is empty list. Okay. So I'm going to do for X in A. Okay, so this one would actually iterate through or find an X in A, okay, each time. So it will be 0, 1, 2, 3, 4, 5, whatever, okay? And then what we'll do is that Y equals X squared. So far, okay?
Yeah.
How about Harrison? Are you okay?
Yeah.
So every time you find an X in A, so first time it will be 0, second time will be 1, third time will be 2, okay? So you find Y, okay? And then you add the Y to B. So B dot append. So we put the Y into B. Okay, so that's print B. Up to here, okay? Up to here. Up to here, okay? So this one, actually, you got what? This one was stored as square. And it will be 0, 1, 2, 1, 4, 9, 16, 24, 25, 36. It will be the square sequence. So that's the use of the list. Titus, is that okay so far?
Yeah.
So a list is a sequence. Okay, a list is a sequence. So this is square number 1. Let's actually save as.
Dr.
Yeah.
Chow, I have a question.
Yes, go ahead.
What does append do?
Append just B originally is empty. So we got a Y equals 0 square. We add it to it, it becomes 0. Then Y equals 1 square. we add a 1 to it, it becomes this. And then y equals 2 square, we add it to it, it becomes 0, 1, 2. So the adding the element y to b is called append.
Okay, thank you.
Is that okay? Just add one element to b. That's not hard to understand, okay? So this one, adding, okay, not this one, okay? I'm actually on square 2. Let me save. Let me open the square 1 again, okay? I want to put it on the square 1. Square 2, I'm going to teach you something else, okay? So this is square 1. Square 1 is adding a y into b list, okay? Okay, let me save but close. We don't want to work around. Oh, so this one, we finish it. But this one is hard to actually generate this. So how about this? Let's do this. Let's not using this. Let's do using range function. So range 0 to 11. This means from 0, 1, 2 to 10. Not including 11. So this is 0 to 10. Okay. But this range is not generating a list. It will generate a tuple. So that's converted to a list. Is okay so far?
Yeah.
And this one, you create the same thing as a save. Okay, you create the same thing. This actually is square number 2. Let's save as square number 3. Okay. So I'm going to do a more advanced version now. So this one is square number 3. I'm going to erase the whole thing. I'm going to say b equals SQ, okay, or actually, let me see, don't say the SQ, let's call it x square for x in A. This one we call it comprehensive list. So you get an A from X from A, you calculate the X square, you put it on B. And this will do the same thing. Does that make sense?
Yeah.
So comprehensive list. The same with using for loop, okay? These are more advanced ones, but I still teach you these, okay? Okay, good enough. So let's save for square number 4. Even harder, okay? Even harder. I just want you to see all possibility. You need to know square 1 and 2, okay? 3, 4 are optional. It's more expensive, advanced right now, okay? So number 4, we do figure, okay? Plot A and B, show, okay? And we want to plot it so from PyLab, import star, okay? Import star, this figure, plot, and show 3 functions will be getting from the PyLab. Okay, and you said it's number 4, square number 4. Okay, I just want to show you the power of the list. Okay. It creates a square curve. This is data science that I eventually want to teach you. Does that make sense? Does that make sense?
Yeah.
Yeah.
We learn Python because we want to study data science. We are not learning Python for fun only, okay? Java, we want to work on the database and work on the website design, back-end website design. C++, we want to work on the game design or fast engine design for high-speed computation. JavaScript, we want to work on the front-end website design, okay? We learn the language for some purpose. So I teach 4 languages in high school, want you to get prepared for your future curriculum, extra curriculum, the competition, hackathon, and the user code competition, and also project and research in high school, okay? Sarah, is that okay?
Yeah.
That's why I have you in many languages right now, okay? You have to work hard. You are entering the core of computer science now, okay? Titus, is that okay so far?
Yeah.
We want you to study programming language earlier than your classmate, okay? Someone just get a course from high school in junior or senior year. We want to speed you up, okay? So you can learn some data science and in future you can do competition, okay? And we teach you those 3 and 4. That's harder right now, but you need to at least understand 1 and 2. 3 and 4 are optional. If you can understand it, you understand it. We eventually will still come back to this, okay? Don't worry. But here I just show you the power of the list. Okay, the power of this. So today we finish the string list tuple, okay? These are done. Let's move on, okay? So variable, you do numbers, these are okay. Constant, you know constant what it is. Okay, for this one, okay. Name, your variable cannot start with number or sharp sign. In the variable in the middle, the name cannot have a dot. Okay. The name can only be starting underline or later, and then followed by later or number or underline. Okay. And lowercase and uppercase are different variables. Okay, that's something you need to learn. Okay, and make your variable rememberable. Okay, don't create some variable name like this. So usually when you give me a file name like exercise 3.1 problem 1, okay, .py, I'll told you not do it, right? I want to run your program. I need to write Python and then exercise 3.1 underline program exercise 1.py. I may make mistake, okay? So how about you just call it Q1.py? Is that okay?
Yeah.
Hello? Does that make sense? And when you do programming, your program name, your variable name is so long, you are tricking yourself. You're not going to help you to do quick computation. Okay. So when you are in the exam, say you are taking the AP exam, I would actually suggest you to make the name more readable. So basically the professor can read your variable more clearly. In that kind of situation, make the variable name a little bit longer, still don't want you to write it down super long, okay? Just a little bit longer. If the variable is for yourself, I would just call it X1, Y1, Z1, okay? I don't call it like temporary variable 1. Okay, that actually is too long, okay? That actually too long. Waste your time to do typing, okay? Expression right here, you have plus, minus, star, slash, integer division, double slash, star power, and the percentage sign for remainder. So right here, we emphasize on division, integer division, and remainder, okay? We emphasize on these 3 things. Okay. So let's look at one thing. If we have something called 17 divided by 3, Harrison, what should I get?
For the remainder.
everything. If I give you a 17 divided by 3, what will happen? Do this a long division.
5 remainder of 2.
Okay. This we call it integer division. So you need to do 17//5. This is integer division. This one is taking remainder. So this one is 17 modular 2. Does that make sense? Hello, does that make sense?
Yeah.
Shara, are you okay so far?
Yeah.
Okay, I post it in the group. Okay, later you can take notes. Let's go back. Okay, let's go back.
I have a question.
Yes, go ahead.
So when you use integer division with the / what will it return if you have a remainder?
It just truncate the remainder. You just get the 17 divided by 5, the integer part.
Okay.
Double slash, you just get the integer part. So the remainder part, you want to get it, you will use percentage sign.
Okay.
Now another division that's not integer division. So another one, you do 17 divided by 3, you got 5. 15, you got 20, you got 0.6. 18, you got 20, so you got 5.6666666. Okay. This one you do 17 single/3. This one is a real division. Okay. Is that okay so far? This probably answer your question.
Yeah.
So this is called real division. So integer division and real division are different. You have to check in what condition, what would you like to have? Okay. Sarah, is that okay?
Yeah.
And this one is quite different from Java, okay? Java use operator type to check it. We don't use operator type to check it right here, okay? Harrison, are you okay?
Yeah.
So this is the division. Next one, the power. Okay, power, we actually use it already. We use the XD times XD, okay? This can be written down as XD squared, so star 2. So if you have X cube, that would be X star 3. Okay, it's the power. This is X raised to the power of 3. Any question so far?
No.
Okay, so that's the table. Okay, numerical expression you need to know. Next one, okay, it show you the example. We don't show it anymore. This one is the evaluation order. This evaluation order, you need to follow the mass order. Okay, so it's P E M M D A S pandas. Okay, parenthesis exponent multiply division addition subtraction. Okay. So Harrison, did you learn this from your teacher?
Yeah.
Okay. So the execution order is the same. It's called pandas. Okay. Any questions so far?
No.
Okay, so this is pandas. Okay. We teach you the pandas, and later when you need to evaluate the value, okay, you have to use the pandas. Okay, this one, okay, let's move on. We want to finish this one, chapter 1, and then we need to move to chapter 2, a little bit of chapter 2 today, okay? So we don't waste our time here. This is okay. Type conversion, we teach you before, okay? We teach you before the type conversion. Basically, you just use a type in front of it. You convert if it's legal, okay? Next one is the statements. So each operation, each line of the code is called a statement, okay? It's called a statement. So x plus 2 is a statement. X equals x plus 2. This means the new x equals the old x plus 2. So this one, you fetch a 2 from the memory. So that's a 2. So 2 plus 2, you assign it back. So it's a x, you store as 2. You get this value to here, and then add a 2 to it, and then assign it back to here, so it becomes 4. Is that okay so far?
Yeah.
Yeah.
This is simple, okay? So I don't waste time. So this equation, we are very good at it, right? We already explained it. I don't waste my time, okay? Type conversion, we finished it already, okay? So use the function. You even can evaluate using eval function to eval a string into a coordinate format, okay? The tuple format, okay? So we finish this chapter 1. I will move on to chapter 2, okay? Conditional, okay? What time it is? Okay, we still have some time. Let's work on it, okay? So this week, you work on chapter 2 homework should be fine. Okay, should be fine. Chapter 2, we do have data type and operators. What happened? This is chapter 1, I'm sorry. I don't want the chapter 1, I want the chapter 2, okay?
Dr. Chow,
Yeah?
like this week's homework is chapter 1 and chapter 2.
Chapter 1, yeah, you should
Yeah,
finish. Chapter 2, you can also finish it, okay?
okay.
So first thing is that chapter 2, we have flow chart. So we teach you character and string, Boolean expression, and control statement, okay? We'll try, okay? Let's see. First thing, before you design a program, you need to draw flow chart, okay? So let's look at flow chart. So flow chart is a graphical representation of an algorithm, and parameter use the program planning tool. So it's a program planning tool, okay? So we draw the flow chart. We call it flow charting, okay? So flow chart, you have terminal, input, output, and processing, and decision, and the connection box. So first thing is a terminal. Terminal means that the starting of the program or stop of the program. Okay. And then this is a parenthesis diagram, parallelogram. Parallelogram is actually the input output box. So processing is a box. Okay. Diamond is actually decision. Connector is jumped into another box. Okay, so let's look at the event.py program. Okay, so the event.py program, if we draw the flow chart for it, okay, so initially it should be a terminal. Let's call it start. And after start, you do read in. So you will say, let's see, it's even. So you read in n equals integer of some input. Okay. And then after that, you check if n take modular by 2 equals 0. If yes, you come to here, you print even. If not, it's not. You print odd. And then when you finish, you come to another terminal, let's say end. Is that okay so far?
Yeah.
So this is the flow chart that you need to know, okay? Let me take a picture on this. So this one is a small flow chart. I just talk over the flow chart. That's something you need to know, okay? I use the event program to do it. So the connector circle is jump to another page if your program is too big, okay? So right here, we don't do that, okay? We don't do that as an example. So this one is a flow charting, okay? So before you design a program, you do use flow chart or pseudocode for it, okay? That's a flow chart, okay? To find the maximum. Any questions so far?
No.
Next one is a Boolean value. Before we talk about it will be yes or no, but in the computer, yes, we store as true, capital T, okay? No, we call it false. Okay, no, we call it false. Okay, now finish it at the Boolean value. Okay, and then they are comparator that's then equal, double equal sign, greater equals, greater than, not equal. So in math, this one is that's then equal. In math, you use double single equal sign, but here you check whether it's equal, you use a double equal sign. Single equal sign is called a sign. Okay, called a sign. Less than equals like this, not equal in math like this. Okay. So remember Python, you need to write in this format, not in this low format. Okay, not in this format. Okay. Character, we talked about it already. Order and the char, we talked about it already. Okay, so here I don't waste time to talk about char and Unicode. Okay, Unicode we also show it. Okay, let's move on a little bit faster. String is the combination of the characters. So we have available one equal hello or available two equals Python programming. Okay, so right here you have the hello and the there. You plus them together. So Bob would be hello there. Okay, string 3 is 1, 2, 3. String 3 plus 1, you become not working. Okay, let's check this in the idle. Okay, so let's assume you have the S equals ABC. Okay, so you do C equals S plus 1. It's not okay, but if you do C equals S plus str of 1, you convert 1 to string, then you will become ABC1. Is okay? So the plus sign cannot work on a number. You have to work on a string. So convert a number to a string is using str. Does that make sense?
Yeah.
So Sarah, remember that in Java, we don't need this str function, okay?
Okay.
Right?
Yeah.
Here you need to have it, okay? Here you need to have it. Okay, I think the other things okay. So if you want to get the every value from it, you use the index, okay, the number, okay? So let's see. So let's create another new file. This one, let's call it ASCII 3, okay, .py. I think we have ASCII 2, okay, anyway. So the alphabet equals Okay, 91. Okay, so you get every letter, and then you actually convert it to a character. And then after that, you do one thing. You do quote.join. You join each character together to form a string. And then you print. This is more advanced technique, okay? So this one called ASCII. Actually, we don't have ASCII 2, okay, but it's okay. Let's call it ASCII 3. Is okay? This is more advanced technique. Let me explain one more time. So basically, you have 65 to 90. Every time you get a number that's called X, and this X, you convert it to character. And then you form a string of a list of A, B, C, whatever. And then this whole thing, you do join the whole thing into a new string that's empty. So everyone got joined into there, and it becomes a string. And the alphabet is A to G. Is that okay so far?
Yeah.
This is one way to do advanced coding, converting a list back to a string. Okay. So now I want to access each individual string. Okay. I actually get the alphabet. The alphabet is actually a whole string, right? So right here, let me do this. Let me do quote, comma, alphabet equals this, okay? And then after that, I do print, okay? And I do for each character in alphabet, okay? I get a X equals the order of the character, and I print, okay, X, I'm sorry. Okay. So every time I get a character and then print it. Is that okay so far?
Yeah.
Okay. First, I create an alphabet. That's a string. And I get every character and it's getting its article. Harrison, is that okay?
Yeah.
Can you understand or no? Is that too hard?
If I don't understand, I'll just look back on the video. It's okay.
Okay. That means you are a little bit confused.
It's okay. It's a little bit.
Okay. How about Titus? Are you okay?
Yeah,
Really understand or you are confused as well?
I understand.
Okay. Making sure. Okay. So this one's ASCII 3. Let's save us ASCII 2. Okay. Big will save. Okay. So this one use a traditional way to do it. I'm going to rewrite it. Okay. So let's be stupid this time. So alphabet is an empty string, okay? And then we want to do this. We want to do for a number X in range, okay, 65 to 90. Okay. Then number equals this character equals the CHR of the numbers. okay? Then alphabet equals alphabet plus the character. Okay, this is a stupid way to do it, okay? So at this moment, after that finish, you print the alphabet, okay? If we don't use a comprehensive list, that is too much, okay? That may be too hard. So let's try this one. It's actually A to G, okay? Oh, we are missing something. So this one should be 91, okay? 91. Okay, so we have an alphabet and then we change line. Now we do for I in range the length of the alphabet. Okay, so this one, the length of alphabet is 26. So I will be 0, 1, 2, 3, up to 25, not including 26. Okay, so we say the character is alphabet i's value. So I equals 0, you will get A. I equals 1, you get B. Okay, and each time you get a character. So print character, and that's save, and let's run for it. So this is a stupid way to write, okay? Previous one's advanced way to do it. So this one get every character like this. Any questions so far? So this one just tell you you have a B, C in the string. This one is the alphabet 0. This one is the alphabet 1. This one is the alphabet 2. Is that okay?
Yeah.
If you want to get each letter, you use a bracket. It's the same as your tuple. Tuple you also use the bracket. That's called array indexing. So here you do this one. Variable 1, 0, that would be H. Variable 1, 0. So this one it will get, I'm sorry, this one will get H here. This one 1 to 5, not including 5, 1 to 5. So it's actually is 1, 2, 3, 4, not including 5. So it's a Y T H O. Okay, so it's a H, then Y T H O. Okay, this we call it slicing. Slicing when you have a string 1 to 5, that means 1, 2, 3, 4. You get these 3 characters out. Okay, that we call it slicing. We'll teach you more advanced slicing next week. Okay, this week we're up to here. Okay, so this is H. If you do Y variable 0 is H. Y variable 2, 1 to 5 is this. Okay, so we have a banana. Okay, fruit equal banana. So fruit 1 you get A. Okay, X equals 3. X minus 1 is 2. So fruit of the 2 is N. Okay, any questions so far? Any questions so far?
No.
No? Okay. And if you want to find the length of the fruit is banana, so the length is 6. Okay. So length is a function to find the length of the string. Okay. And you can update your string, okay? And they are string escape character and then slicing. Okay, this we will cover it in next week, okay? We are too complicated. I cannot finish it. So today we are up to here, the update of the string, okay? Any question?
No.
Next week we'll finish the string and the tuple and list. Okay. Let's see. We'll finish the string. Okay, we'll finish the string next time. And then one-way selection. Okay, next time. Any question? No question. We are up to here. Okay.
I have a question.
Yes, go ahead.
What's the difference between a tuple and a list?
List is a fixed size. You cannot change the size.
Okay.
I'm sorry, tuple. Tuple is a fixed size.
Okay.
Usually it's for coordinate. 2D is 2D. You cannot add another number to it. List is you can make it longer. Okay.
Okay.
That's the basic difference. Any other question? Again, the string we are actually teaching more detail right now. Okay. And list and tuple in the other chapter, we will also talk about it. Okay. Any other question? How about Sarah? Do you have question?
No.
Okay, that's it for you. Okay. Good night and bye-bye.
Bye, thank you.
Thank you.
Bye-bye.
Bye. Thank you.